Hello, this is the AQA practice paper number 2. It's a calculator one for the year 2022. In this case it's 76 marks, but please remember that in the real exam it will be 80 marks. The time is the same, 1 hour and 30, and these topics are hopefully matched to the topics that are coming in this year's exam. So let's start. Now I will be using a blue pen just to make it stand out, but please remember that in the exam you're meant to use a black pen. Have your calculator handy and make sure you know how to use your calculator. Question number 1 says how many minutes are there in 3.5 hours, and we're asking for minutes, so they're basically testing that you know that in 1 hour it is 60 minutes. We have 3 hours, so we have 3 lots of 60. Put it in the calculator if you don't know how to do it, but 3 lots of 6 is 18. So we end up with 180 minutes. And then we also have half an hour, and half an hour you should know is 30 minutes. So when you add 180 plus 30, you end up with 210. Question number 2. And question number 2, we have a mixed fraction and they want us to write it as a improper fraction. The denominators are already correct, they're all 4, so we're just having to work out the numerator. And the numerator is done by basically saying 2 lots of 4 and then add the 1. 2 lots of 4 is 8, plus 1 is 9, so 9/4 is the correct answer. Question number 3. Question number 3, we have a fraction and they're asking which of these 4 decimals is closest to that fraction. So let's enter our fraction, and the fraction is 39 over 800. Change it to a decimal, and so that fraction is 0.04875. So now we need to see which of these decimals is closest. Now looking at them, you can see that here we have 0.48, 0.48, 0.49, so those two are the closest, because this one here, if you think of it, is 0.050, and this one over here is 0.040. So those two are too far away, much further away. So we ended up with these two. So we now need to see which is closest. Now if you are not confident working it out by looking at it, what you can do is you can subtract both of these from this number and see which gives you the smaller number. Okay, so we're going to have 0.04875 take away 0.048 for that first one, and when you do that, 0.048, okay, just typing in what we have there, that answer comes out to 0.00. Well, you can actually see what's going to come out, can't you? Because that 48 is taken away from that 48, so we're left with that 75 there. Okay, so that's the answer for that one. And here the same, we'll take away 0.04875. When you put that in your calculator, you'll end up with 0.049 take away 0.04875. We end up again with another answer, and in this case it comes out to 0.0025. Okay, and you can see that here this one is much smaller number than that one, and so we end up with that being the correct one. Okay, but as I said, normally I would just look at the numbers and see which is the closest, and we can see that 49 is closer to 4875 than 4800 would be. Okay. Question number 4. Question number 4 is asking or saying that we have x is greater than 5, but it's also and less than or equal to 9. So we're looking for the case here, which of these is the correct one. And this is where you just have to understand the notation, because the answer is the one over here, because in this case x is bigger than 5, which is the case here, x is greater than 5, and here we have the equal, so x is equal, but it's also smaller than 9, and here it says x is less than or equal to 9, so these other ones are no good. Okay. Make sure you do know the notation for inequalities. Question number 5. And question number 5 is looking at a shaded shape and they're asking us to tick the correct box. And what we have is, looking at the shaded part, is it less than a half, exactly a half, and more than a half? Okay. So before we can answer that, we need to know how many little squares we have in total. So we have 1, 2, 3, 4, 5, 6. 6 times 3, so we have 18 squares. Now you can count them up to get 18, but 6 times 3 is 18. So if it were exactly a half, you'd be dividing it by 2, which would be 9. And so the question is are these more than 9, less than 9, or exactly 9? So let's see. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 is less than 9, so it's less than a half. If you go to the second part, we have the same question, but different number of shaded parts. But remember, we know that half is exactly 9. So the question is, do we have 9 boxes here, shaded, 9 little squares? 1, 2, 3, 4, 5, 6, 7, 8 full boxes. That half and that half together would make 9, which means that we have more than 9, because 9 and a half. So in this case, we have more than 9 boxes shaded, so it's more than half. When you get to question 6 says measure the diameter of the circle in centimeters. And so for this question, you need to have a ruler. Make sure you have a ruler in the exam. And they're testing that you know what the diameter is. And the diameter is the distance from one side of the circle to the other side, passing through the center. In other words, the longest chord that there is. Okay, so in this case, you see I'm lining up the starting point. I go through the center, and so if we look at it, it comes out to about 5.1.2.3. So when I do that line, if you want, let me just mark that line so you can see what I'm doing. So basically it's that line there. Okay, that's the diameter. When I measure that, it came out to 5.3 centimeters. Okay, let's have a look at question number 7. And question number 7 is telling us that we are allowed to only use a plus and a times, an addition and a multiplication. And we need to put those signs or symbols or operations into each of these calculations such that the answer that comes out is a multiple of 5. Show 3 different ways, so we can't repeat it, they all have to be different. And this is a case of a little bit of trial and error and making sure that the answer comes as a multiple of 5. So things like 5, 10, 15, 20, etc. You get the picture. Okay. So let's just jump in and test out. Okay. So if we do 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 is a multiple of 5, so that looks good. So let's write it in there. And 10 is definitely a multiple of 5 because that is 2 lots of 5. Okay, so now we're going to look at the second one. And the second one, we basically again are looking for a multiple, but we can't do only addition because we've already done addition. Okay, so let's try something else. Now remember that the order of operations matter. So what do you put in? If it's a combination of adding and multiplying, you'll do the multiplication first. Okay, so let's try doing some multiplications. So 1 times 2 is 2, 2 times 3 is 6. Well, that's nice because 6 and another 4 would give us 10. So that seems to be working. But there is an element of trial and error, and you just try it and see what comes out. Okay, I've been lucky so far that the things I've tried have worked. Okay, now we need to try other things. So what could we do? Well, I did multiplications there, so how about I do multiplications over here? Let's just see. So if I do 3 times 4, that's going to be 12. 12. If I do a multiplication here, it would be 12 times 2 would be 24. 24, I need a multiple of 5, so it ends in 5. Okay, so let's add 1. That will work, won't it? So let's do that. So multiply, multiply, add. So we're going to have 3 times 4 is 12, 2 lots of 12, 24, plus 1 would be 25. And 25 is definitely a multiple of 5 because that's 5 times 5. Okay. Now, if you experiment and try, you may have come across some other options. Other options you could have done is done like I did here, multiplication. 3 times 4. 3 times 4 is 12. And then you might say, but 12, if I were to add another 2 to it, 12 plus 2 is going to be 14, and 14, if I then add 1 onto it, I get 15. So you could have done that and ended up with 15. Okay, just to show you that there are other options out there. Okay, let's move on to question number 8. And question number 8 tell us that this is a parallelogram, and so they're checking that you know what a parallelogram is. And a parallelogram means that the top and the bottom sides are parallel to each other, and the left and the right hand sides are also parallel to each other. Okay, that's the definition of a parallelogram. So in this case they're telling us AB, and AB is the top, is parallel to DC, which is the bottom, and that is definitely true. They're also telling us the angle A, so they're saying that this angle here is equal to angle C, and it is, because all the rules with parallel things means that those there are equal and those there are equal, so this is true. Then it tells us that the parallelogram has 2 lines of symmetry. Now if it were a rectangle, there'd be 1 line of symmetry, actually 2, because you could cut the rectangle like that, but here you can't, because if I were to draw a line of symmetry like that, you can clearly see that the distance on this side is shorter than the distance on that side, so it won't match up. And the same if you were to do it that way, it won't work, because the distance going from this side to that side doesn't work. So in this case the parallelogram has no lines of symmetry, so this is false. And you go to the last one, it says the parallelogram has rotational symmetry at order 2, and that means that if I were to rotate this fully by 360 degrees, the shape would match itself twice. And that's true. If I turn it by 180, the shape looks the same. So that's 1. Then I turn it back 180 and it's back to where it started. So that is in fact, let me just bring it up to you, true. Okay. Let's move on, and we are now on to question number 9. And question number 9 is a little bit of algebra, some basics of algebra, and they're saying which of these matches 4 times x. Now when we do algebra you don't tend to write multiplication because it can look like an x, so in fact 4 times x is most often written as 4x. So they're just testing that you know how to write the notation on multiplication in algebra. And here we have another one. They're saying that a plus b, which of these is the same as a plus b? Well, you know that 2 plus 3 is 5 and 3 plus 2 is also 5, so you can change and have b plus a would give us the same answer as a plus b. Okay? These wouldn't be the case because that's in fact a times b, b times a, 2 times a times b, so they're not the same ones. Question number 10 has a drawing of a house. They tell us that's the height of the house, it's the front of the house, and in this case it says the actual height of the door is 2 meters. Now clearly that's not 2 meters drawn here because it fits on the paper, but it says work out the actual height of the house. So to do that we're going to have to scale, and what I mean by that is we have what is happening in the drawing and what is happening in the real situation. And they tell us that in the real situation, if we look at the door, the real situation, the door is 2 meters. Okay, but in this picture it isn't 2 meters. In this picture, if I were to measure it, you can, sorry about the reflection, but you can just about see there, if I line up with the door, it is 1.123. It's about 1.3, 123. So it's about 1.3 centimeters. Okay, and they're telling us that the height of the house is what we want to find out. How high is it in reality? So in other words, I'm trying to find out what is the real height of the house. So I'm just going to write here height. Okay, but to do that I'm going to find the height of the house in the picture. And when I look at the height in the house in the picture, I have 1 centimeters, 2, 3, 4, 5 centimeters, 5.1 centimeters. Okay, so I've lined up the information I have for the door, for the height, what's in the drawing, what's in the real life, and now we have to find out what it will be for the real height. And to do that I'm going to find out what's happened here, what has it been scaled by, how many times I have to multiply 1.3 to get 5.1, and then I will do it on this side. Okay, to do that we're going to work backwards. I'm actually going to say the answer was 5.1. I'm I'm going to divide it by what we started with to find out what it's actually scaled by. So get your calculator out, and we have 5.1 divided by 1.3 comes out to not a very nice answer. It's a fraction. Change it to a decimal. See, it's not very nice, is it? So I'm just going to keep it there, and so that comes out to 51 out of 13. Don't worry, it's a calculator, so I'm just going to use that information. So in this case, you multiplied by 51 over 13, and so this side you're going to multiply by 51 over 13. So I have that information already on my calculator, and I'm going to multiply that by 2. And so that's the answer. So now I'll change it to decimal. It doesn't come out very nice, but it comes out to 7.846, etc. meters. And now I'm going to just use a level of accuracy that matches a picture and or this question, and it said 2 meters, so I'm probably going to use something like 7.8. I'm going to round it to 1 decimal place. Okay, no point having more than that because we started with 2 meters, so if I have more than that, it's getting a little bit too accurate for the information we have. But I've shown it just in case they do want it for 3 marks. Hopefully in the question it'd be nicer numbers than what we ended up here with. Question 11 is about understanding mode, median and range, and they tell us there are 3 positive numbers. So in other words, we're not allowed to use negative numbers. Here are the positive numbers, and they're asking us to work out what are the 3 numbers such that the mode is 5, the median is 5 and the range is 5. So I'm going to start off with the median, because the median is the middle number, and if they tell me the median is 5, I'm going to make my middle number 5. Okay. Now, if it's the mode and the mode is 5, it means that I need at least 2 5s or even 3 5s, but I can't have 3 5s because if they're all 5s, then the range is going to be 5 take away 5, which would be 0. Okay, so let's have another think. So one of these will be a 5, but I don't know which. Now if I put my 5 here and the range is 9, it means this number here has to be smaller. If 5 take away 9, which would be a negative answer, and they said our numbers have to be positive. So what I'm going to do is I'm going to put my 5 here, and then I'm going to say 5 plus 9. 5 plus 9 is 14, because the range is the biggest number, take away the smallest number, and it should come out to 9. So 14 take away 5 is indeed 9, and so we have found the missing numbers. What about question 12? Well, question 12 is understanding straight line equations, and this is more just general, not general knowledge, but it's like facts that you need to know. And this is an equation of a straight line, linear equation, and I know that because basically that has a power of 1. Yes, it's not a square. Square would be a curve. So here it says what's the gradient, and the gradient is always the number that's multiplying the x, in this case 4. And the second question says what's the intercept, and the intercept is where the line will cross the y-axis, and that happens when x is 0. If I put 0 in there, I get 0 times 4, and you can see that the y will cross at -5. So this bit here is your intercept, and in this case it's -5. That's just a thing of memory. Question 13 is a tree diagram. Just making some room up there so that we can fit this on. And the tree diagram is looking at some experiments, and they tell us they're independent, which means they're not connected. So what happens in the first experiment doesn't affect what happens in the second experiment. And they tell us that the experiment can work or it can fail. They've given us a probability for success, which means we need to find a probability that it will fail. And as you know, total probability adds up to 1, so 1 take away 0.4 leaves us with 0.6 down there. Now we will look up here, and they've said this one here, the chance or the probability of failure is 0.25. So if you do 1 minus 0.25, you'll end up with 0.75. Okay. Now what happens in the second experiment doesn't matter, it doesn't change. depending on the first. It will always be this. So in that case, what happens here will happen there. So in this case, it will be 0.75, and this one down here will be 0.25. So that's 2 marks completing the tree diagram. But then we look at part B of this question. It says, work out the probability of success in both experiments. In other words, we're going along here because we want to get to success, and then we need to go along this branch to get to this success. So we're going along that branch, so the probabilities along that branch are 0.4 and 0.75, and when you travel along the branches you always multiply. So let's have a go at the calculator. So 0.3 times 0.75. You can just about see it there. Oh, I made a mistake. It's not 0.3, isn't it? 0.4 times 0.75. That's a good thing on these calculators. You actually get to see what you type and press equals. It says 3/10. Change it to a decimal, 0.3. So the answer for this one is 0.3. And I'll write the answer down there. Beautiful. Let's have a go at question number 14. Now, question number 14 has 2 offers, and these are to buy some batteries. First offer, you buy them in packs of 4. Sorry about this, you can't see. Let me bring it down. And here we have packs of 5 for offer B. The price is obviously different because you're getting a different number of batteries, but there's also some offers. Here it says you get 1/3 off the price, and here it says you buy 3 packs and you get 1 free. Zach wants to buy 40 batteries. Which is the cheaper offer? So we're going to have to do both calculations and find out which is cheaper, and they tell us they want to see our workings because it's worth 5 marks, and so we have to show what we've done to convince them. Okay, so I'm just going to push it up so I can just about see it, but not fully. So let's have a look. Offer A. Now, how many of these packs do we need to buy? Now, if you buy 1 pack, you get 4, so I want to know how many of those I need to buy. So I want to get 40 batteries. Each pack has 4, so that tells me that 40 divided by 4 is 10, so I need to buy 10 packs. Now, each pack is £2.52, so we're going to have 10 lots of £2.52. You put that in your calculator and it will come out to £25.20. So that's the cost if there's no offer, but they tell us that there's 1/3 off, so we're going to find out what 1/3 of 25.20 is. You can put that in your calculator by saying 1/3 of 25.2. You don't need to put the last 0 in there, but I'll do it anyway. And it comes out to that answer, so let's change it to a decimal, 8.4. So you get 8.40 pence off. And as you know, off means you're removing it, so it was costing £25.20, and we're taking £8.40 off. So the cost of those batteries will be £25.20, take away £8.40, and it means we have £16.80. So the amount you would pay for that one is £16.80. I'm going to highlight that that's what we calculated for that question. Now let's work out question B. And question B, we still have to find, just like we did before, how many packs do we need to buy. So we want 40 batteries, or he wants 40 batteries, and each pack has 5 batteries. So 40 divided by 5, if you're not sure, put it in your calculator, it comes out to 8. So in this case, you obviously need to buy less packs because you get more batteries in each pack. Now before I jump in, here I jumped in and worked out how much it would cost for all of them, because I needed a total before I found what 1/3 off was. But in this case, I'm going to actually think about what's happening. In this case, you buy 3 packs and then you get 1 free. So in other words, you get 4 packs, but you only pay for 3 packs. Yeah. So the question is, how many groups of 4? And here, well, actually 8. That means that would happen to twice. Or if you're not sure, just do it again. Okay. So here I have 8 things. 8 things in total, 8 of these packs. But you can see that in doing that, I'll only be paying for 6 packs. So now we can say 6 lots of £2.75. 6 times 2.75 comes out to, sorry about that, you can't see the calculator, comes out to £16.50. 50. Okay. So looking at that, then it's quite clear that what comes out as the cheapest one is offer number B. Yeah, because you compare those and you can see that B is cheaper. Perhaps not too much, but you know, it's cheap enough that we can actually say which one is cheaper. Now, so apologies, I'm making my handwriting not very clear. You need to make sure that they know that when you write it, it doesn't look like an A. Okay, so as long as you make sure it, in this case, it looks like a B, then we're fine. That's why I went back and changed it. Okay, question number 15 has two parts to it, and we're looking for the missing numbers in the first one. And so for that, you need to kind of look to see what's happened. And so you're kind of thinking, well, what's happened between there? And you can see that 2 plus another 3 gives you 5. And then you're looking between those, what's happened to that? Well, 5 plus another 6 gives you 11. And then you look and see what's happened here. And 11 plus another 9 gives you 20. So notice we're going 3, 6, 9. It's going up here in threes. So 3, 6, 9. So the next one will be add 12. So we're going to do 20 plus 12, which will be 32. And then the next time would be plus 12 plus another 3 would be 15. And let's check it. 5 plus 2 is 7. 3 plus 1 is 4. Good. So that seems like it's working. And the next one, 15 plus another 3 would be 18. So you want to do 48 plus 18, which will give you 65. But if you're not sure, just make sure you put it in a calculator, and you had 47 plus 18, and indeed it was 65. Always check if you're not sure. Okay. Now here is a different sequence. We don't know what it started with, but then we had 2, 4, and then we have something else. And it says write down a possible rule for continuing the sequence. And there are a couple of options you could use, or in fact probably more than a couple. One option is you can basically be saying, oh, let's add 2. So we go 0 plus 2 is 2, plus another 2 is 4, plus another 2 is 6. So that's one rule. You could be adding 2. Or another rule is multiplying by 2. So we could go something like 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So there's, and I'm sure there's other ones out there. So you just choose one of those. I'm going to do the simplest, which is just basically add 2. But as I said, you could say something like multiply by 2. Depending on which you choose, you then have to write down what the first and the fourth terms are. So if I'm adding 2, before that, it means that that would have had to be less than 2. So 2 take away 2 is 0. And in this case, 4 plus another 2 would be 6. But if you've done the times by 2, then in this case, that would be a 1, and that would be an 8. What follows? Let's have a look. Question 16, and it says work out 1/4 plus 0.5, and this is where you either know it and you can say, oh, it's 0.75, but if you don't know it, you literally put it into your calculator and I say plus 0.5, and notice the calculator, I've just typed in exactly what is in the question. I press equals, comes out as a fraction, change it to decimal, 0.75. So these calculators, scientific calculators, are really good. They do a lot of the work for you. Question 18 is again testing that you actually just know these facts. What is a cube number, what's a prime number, and what is a factor? Okay, so this is a case of just memorizing what they mean. Cube numbers are numbers that you basically going times by times by times. It's repeated, okay? So in this case, think of like 1 times 1 times 1, or 2 times 2 times 2. The answer to that, or if you want to use a calculator, it's the one with a little, when you do it, any number, and you enter it to the power of 3. Okay, so that's what a cube number means. It means the answer from when you put a power of 3. So that's one example. 125 is a cube number. Okay, so it's asking for a cube number. I'm going to go for 8. 8 is 2 times 2 times 2. But you can go for many. There's lots of different ones. As long as it's a cube number, you get the mark. Prime number, they're testing that you know what a prime number is, and a prime number is a number that is only divisible by itself and 1. Okay, in other words, 2, 3, 5, 7, etc. And you can choose a prime number and write it down. It's a good idea to memorize them. I would definitely know the first 5 cube numbers. 1, 8, 3 times 3 times 3, 27, 4 times 4 times 4, 64, 5 times 5 times 5, 125. And prime numbers, I'd learn and memorize the first 20 prime numbers, or at least the first 10. Now factors are what make this number up in a multiplication. So you can imagine something like 9 times 100, or you can imagine something like 90 times 10. So there's so many different options. I'm just going to go for a nice easy one, 10. Because if I divide 900 by 10, I will get a whole number coming out, so that's a factor. Question 18 has given us a bit of algebra and it's asking to factorize. Factorize means you're going to put a bracket and you're going to take out a common factor. In this case, you notice we have an x here and we have an x there, so a common factor we can take out is x. So x times what would give x squared? Well, it would be x. I'm just going to give myself more room. I just realized I didn't give myself enough room. Okay, so we've done that. X times x is x, and if I take, not take, but if I divide that by x, I'm going to be left with 1. X times x is x squared, x times 1 is x, and then the negative is what's there, or the minus. Okay. Now they're asking us to multiply out and simplify. So we're going to work first on this bit here. So we have 5x times x, which will give us 5x squared. And then we have 5x times negative 3, so positive times negative gives us a negative. 5 times 3 is 15, and we had an x. So I've done that bit there. And now I can put this bit that we haven't done at the end. Okay. So now we have to simplify it. Now this is squared, but these are not squared, so this one's going to stay the way it is. And here we have minus 15, minus 8, so we're going to group those all together, so we're going to get minus or negative, and in this case we have negative 15, negative 8, see, I can actually use my calculator to do it for me if I'm not very happy, and I see it's negative 23 or minus 23. And now don't forget to put the x there. Okay, let me make my 3 a bit more obvious. Excellent. So we're now on to question 19. And question 19 is a ratio one. It says Abby and Judy share some money. Abby gets 25% of the money. Write down Abby's share and Judy's share in the ratio as a ratio. But remember to simplify it. And we're going to put ours in here. Okay, so Abby goes first and Judy goes second. If Abby gets 25%, well, the total is 100%, so 100 take away 25 is going to leave us with 75 over here. Yeah. Now that's okay, that might get you a mark, but we need to simplify it. You notice they both are in the 5 times tables. Yeah. But even more than that, you notice that here, how many 25s are there? This is basically 1 lots of 25 on this side. And this side is 3 lots of 25. So if I cancel the 25s, I'm left with 1 and 3. But if you think, oh, I can't do that in one step, you can do it in multiple steps. First, divide this side by 5 to get 5. Divide that side by 5 to get 15. And then you think, oh, how many 5s fit into 5? 1. How many 5s fit into 15? 3. And you will get there. Okay, so you don't have to do it all in one step. Now let's look at part B. And they tell us that Judy gets £19.50. Now remember, the first person was Abby and the second person was Judy. So basically, Judy got or received £19.50. And they're asking us, how much does Abby get? And what we do on one side of a ratio, we do on the other. So we're trying to find out 3 times what gives £19.50. So I'm going to go backwards. And so I'm going to say 1950 divided by 3, which means 13 divided by 2, so 6.5. So 3 times 6.5 gives me 1950. Let's just check. 3 times 6.5 gives us 1950. Good. So in this case, 1 times 6.5 will give us 6.5. So that's how much Abby gets. But remember, we were talking about money, so I should write it as money. So instead of 6.5, I'm going to write 6.5 because £6.50. Okay, we're on to question 20, and question 20 shows us a rectangle and a T-shape. The side of this rectangle is 7, the bottom of this rectangle is x plus 1, so we don't actually know the measurement, but that's what they've told us. And here we have a measurement, or the dimensions. Okay, and they're asking us to show that the rectangle and the T-shape have the same area. So what do we know? Well, area of a rectangle, okay, we know area of a rectangle is the base multiplied by the height, or whatever you want to call it, the width by the length, but anyway, basically we're going to multiply the long side by the short side. So if we look at the rectangle, we have 7 times what we had on the bottom, which was x plus 1. And if I multiply that, I have 7 times x, which is 7x. Now remember, in algebra we don't write the times, so 7 times x is 7x, plus 7 times 1 is 7. So that is the area of the rectangle. We can't do anything else with that. That's what it is. Okay, and if you wanted to, you could write centimeters squared in there because it's in centimeters and that is in centimeters. Okay. So now we're going to look at the T shape. Okay, and the T shape is made up of rectangles. How do you know that? Well, you can see that. Hopefully you can see it. Here we have one rectangle, and here we have another rectangle. So if we work out the area of the top one, we're going to have 2 lots of 2x plus 5. Notice I've stopped writing the times because it can get a bit messy. Okay, but to make this shape, they've stuck them together, haven't they? So we have, this is for that top one. I'm going to work out the area for that one, which is going to be 3 times x minus 1. That's for the top one, that's for that bottom one. But what we do is we stick those 2 rectangles together to make our area, so we're going to stick those 2 together. So now let's multiply out this bracket. So 2 times 2 is 4x, plus 2 times 5 is 10, plus 3 times x is 3x, and then we have 3 times a minus 1 or negative 1, which gives us a negative 3. Okay. So now we're going to collect our terms, and here we have 4x plus another 3x. So 4x plus 3x will give us 7x. Looking good, because those are matching, and they said to show that they're the same. And now we have 10 take away 3. So if we look at 10 take away 3, we end up with 7. And as you can see, that one is the same as that one, so we've done our job of showing that they are the same. Very good. So now we're on to question 21. And question 21 looks like a straight line. Okay, I can see a straight line, AB. And it's saying work out the equation of line AB. So, the equation of a line tends to look like this. Y equals mx plus c, where m is the gradient and c is the intercept. The gradient tells me how slopey it is, and the intercept tells me where it crosses the y-intercept. Okay, so at this stage I can already jump in and write that y equals this. I still haven't worked out the gradient, so I'm leaving it as m, but I can see that this line crosses at 3, so I'm going to say, okay, now we have to work out the gradient, and the gradient is how much does it change, how much does it change in height depending on how much you change in the x-axis. Okay, so to work out the gradient, we need the change in the y-axis. Okay, so we're going to say y1 minus y2 divided by the change in the x-axis, x1 minus x2. So choose 2 points. I'm going to choose that point there. I'm going to choose that point there. This point here is 0, 3. Not very clear, but you can. And this point here is 2, 0. Okay. I'm going to call this one x1 and this one y1, but it doesn't matter. You could call this one x1 and y1. But if I call that one x1 and y1, I'm going to call this one x2 and y2. So now I'm going to substitute it in here, and y1 was 3. Take away y2, 0. x1 is 0. take away x2, which is 2. So when I do that, I'm going to get 3 take away nothing is 3. 0 take away 2 is negative 2. In other words, I can write it as that. So I could now substitute it in there, so I end up with y equals negative 3 2x plus 3. And there we have an equation. You could have written it as a decimal, minus 1.5, but I think that will do. So now we move down to question number B. And question number B is working again with straight lines, but they're testing that you understand that parallel means they'll have the same gradient, because parallel will be sloping by the same amount. Yeah, that means what parallel is. And they tell us it's passing through this point. So if it's going to have the same, if it's parallel, it will have the same gradient. So we can write that y equals 3x, but we do not know what c is, what the intercept is. But what we do know is an x and a y that are on this line. So I'm going to substitute in the y, minus 3, equals 3 lots of 2 plus c. Okay. Let's just go through this. So here I have, I'm sorry, I'm going to go down here. I've run out of space, so let me just move it. 3, okay, equals 2 lots of 3 is 6 plus c. So now you have to think 6 plus what would give us minus 3. Well, you can see that this is going to have to be a negative, because you're going to be taking away to make it negative, and you're going to have to take away more than 6. So it's actually going to end up being taking away 9. But if you're not happy with that, take 6 away from this side to get the c on its own, and you end up with taking away 6 from this side. So 3 minus 3, take away 6 will give you negative 9. So I can now, that will tell me that c equals negative 9. So I can rewrite my equation, which is y equals 3x take away 9. And that is the equation of a straight line for that question. Okay, sorry about it going down there, but I should have written it down on that side, shouldn't I? 21, so now we're on to question 22. And question 22 says a coin that is biased. That means it will not land equally, it will land more times on one side than on the other. And it says it's been thrown 250 times. And they've looked at the relative frequency, in other words, how often it's landing on heads after every 50 throws. So it's thrown 50 times, and in that case you get 0.4 as a proportion of times landing on head. Threw it 100 times and we get the answer. Threw it that time, we get the answer. And you can see it's changing. And here is the answer for 250. And they're asking us what, or circle, which is the best estimate for the probability that it will land on heads. Well, for that, it's always the one with the more times, because if you do it more times, it's giving you a better picture of what's happening. So this is the one we're interested in. And you can see that the probability is 0.3, so we're going to circle 0.3. Now we're moving on to question 23, and 23 is quite nice, except that you need to kind of spot what this question is about, because they give us a trapezium, and you might start to think, oh, it's something to do with area, but it isn't. It says work out the length of line BC, and spot where line BC is. Line BC is down here, so they're asking us to know what is that distance there. Okay, they're asking us what is that distance. Now when you first look at it, you think, oh, how am I going to do that? But in the back of your head you should think, well, I know how to get a missing side of a right angled triangle. Remember Pythagoras? Yeah. So here, if I look carefully, I can actually see that I have a rectangle. Can you see that we have a rectangle? I'm just going to colour it in. Okay, here's a rectangle. Okay, can you spot the rectangle here? Which means that if I'm looking for BC, that is the same as that distance there. And since this was a right angle and that was a right angle, this will also be a right angle. That will also be a right angle. It means that this here will also be a right angle. Which means that we have a right angled triangle. We have the hypotenuse. And if I can know this side, I can calculate that side. And I can, because if this side is 3, I then know that the distance from here to here will be 3. If all the distance from the top all the way to the bottom is 9, then it means that this side here is 6, because 6 plus 3 is 9. So I now have a triangle that basically looks like this. This is 6, this hypotenuse is 10, and they're asking us what is that one. So using Pythagoras, we can say 10 squared, take away 6 squared, and then square root it, and we can put it all in one go into the calculator. So we have square root of 10 squared, take away 6 squared. You can just about see there that I've done that, and when you press it, out comes the answer 8. So the answer is 8 centimeters for that one. So it's a nice question once you look at it and realize what they're after. Question 24 is also a nice question, because this is basically, can you work out the mean from a table? They tell us these are the scores. Frequency is how many times. So in other words, 6 times they scored 7, once they scored a 10, and they're asking us to work out the mean score. So we want to find the total, because if you remember, mean is total score in this case divided by how many. Okay, so we need to find the total score. Well, if there were 7 lots of 6, we would have 7 times 6, which is 42. So here we have 42. 8 times 9, which will be 72. 9 lots of 4, or 4 lots of 9, which is going to be 36. And 1 lots of 10, which is 10. So we add all those together, we will get the total. So we have 42 plus 72 plus 36 plus 10, okay, which equals 160. So in this case, our total score is 160, and we're going to divide it by how many? And we have 6 of these, 9 of those, yeah. So this had the frequency, and the frequency is 20. So 160 divided by 20 will give us 8, but let's just check. 160 divided by 20, and you can see there, comes out to 8. So the mean score is 8. Now we're on to question 25, and question 25 is what looks like an angle question, but it's actually a sneaky way of doing a bit of algebra and angles at the same time. Because what we have is we have different angles marked with basically algebra, and they're asking us to find out what x is. Inside a triangle, the angles all add up to 180, but inside a quadrilateral, they add up to 360. So I'm going to add all these angles, and I'm going to say that it's equal to 360. So we have the first angle is 2x. I'm then going to add it to 2x plus 30. I'm then going to add it to x plus 25. And I'm going to add it to 2x minus 10. So here we have all those angles added together, and when they add together, they will give us a total of 360. So now we will collect all our x's, and so here we have 2x plus another 2x plus an x plus a 2x. So we're going to add all those together. So we have 2, 4, 6, 7, 8. So I made too many, did I? 1, 2, 3, 4, 5, 6, and one more there, 7. So we have 7 lots of x's. Okay. And now we're going to basically look at what we have, and we have a plus 30 plus 25 take away 10. So 30 take away 10 is 20, 20 plus 25 will be 45, so plus 45, and all of that is equal to 360. Now we're going to balance our equation to get x on its own. And to do that, we're first going to remove 45 from this side. But if we do that on the left hand side, we need to remove it from the right hand side. Why am I doing that? Because I want to get this on its own. Okay, so that disappears, and I'm now left with 7x on the left hand side and 360 take away 45 on the right hand side, which leaves us with 315 on the right hand side. 7 lots of x is 315, so on this side I'm going to divide by 7 so that they cancel to just give me 1x, and that means that on this side I need to divide by 7. So 315 divided by 7 gives 45, so x is worth 45. There's our answer. Excellent, we're nearly there. We've got basically 2 more questions to do. Question 26 is a pie chart. They tell us in this pie chart we have the information from election results. We have 3 candidates. They've given us the angle for Mr. Smith. We do not know the angle for Mrs. Patel or for Mrs. Wood. They tell us that the angle for Mrs. Wood would be 24 more than the angle for Mr. Patel. Oh, sorry, Mrs. Patel. And they tell us that in total there was 5,220 votes. Work out the number of votes for Mrs. Patel. Now this is one of those questions where it looks a little bit confusing because it's pie chart and also because it's angles and because it's unknowns and we don't know what these angles are. Now it says this is not drawn accurately, so don't go measuring it because it won't be correct. Okay, so we're going to have to use our noodle to work out what on earth this is. So they tell us that whatever Mrs. Patel has, Mrs. Wood had another 24. So whatever Mrs. Patel had, and I'm just going to call it an unknown because I have no idea what it is, Mrs. Wood had an extra 24 on top of that. So you can use your algebra for this, or you can use a little bit of thinking logically. Okay. So what other information do we need? We need the information that total angles in a circle add up to 360. Okay. So what I'm going to do is I'm going to take away that 64. So we have 360. I'm going to take away that 64 to see how much angles would be shared between Mrs. Wood and Mrs. Patel. So we have 360 take away 64, which leaves us with 200 and, not very clear there, is it? 296. Okay. Now if you don't like algebra, if you like algebra, we can say here we had x plus x, 2x plus another 24 equals 296, and then you can take away 24 just like we did a moment ago. Take away 24 from this side, take away 24 from that side. That means that would cancel on this side, and then we have 296 take away 24, which means on that side we have 272. Okay, so we'd be left here with 272, on this side 2 lots of x, and again you say, okay, divide this side by 2, divide that side by 2, which means that x would be, let's cancel the 2's, 272 divided by 2, which means that x is 136. So that's one way of doing it. I haven't finished. This was just to find out what was the angle for Mrs. Patel, so then I could say what is the angle for Mrs. Patel plus another 24 to find Mrs. Woods. Okay. Oh no, we want to find Mrs. Patel, so that's okay. Okay, so this is the angle for Mrs. Patel. Okay, and this is her angle. But if you don't like algebra, what you could say is that hers, whatever Mrs. Patel was the same for Mrs. Wood plus another 24 equals 296. So then you could say, okay, so let's remove this 24 from here and then split it equally between those two, and you would end up with 136. Okay, we can check it by putting it in here, can't we? 136 plus 136 plus 24 should give us 296. Yes, so that's fine. Okay, so that's finding the angle. But that's not the question. The question is work out the number of votes for Mrs. Patel. So if the full circle is worth 5,220, and we know the fraction that she had, the fraction was 136 out of a total of 360. So this is the angle, the fraction of the angle that she had, multiplied by the total, and when you do that it will tell us how many she had. So we ended up with 136 out of 360 times by 5220, and when we type that all in, you can just about see there, it comes out to 1,972, and so that's how many votes she had, 1,972. Last question, and the last question is a bit of information. 1,000 centimeters cubed is the same as 1 litre. A tank has 45,000 cubic centimeters of water. the tank is leaking, it's losing 0.75 litres every minute. How long will it take the tank to empty? And show you units. So in other words, will it take how many minutes or how many hours, etc. Okay. So what I'm going to do is I'm going to find out, because here it tells me how many litres it's losing. So what I'm going to do is I'm going to change the 45,000 centimeters cubed. I'm going to change it into litres. And to do that, you notice that you need 1,000 of these to make 1 litre. So I'm going to have to divide it by 1,000. And when I divide that by 1,000, I'll end up with 45 litres. So that's how much water is contained in the tank. And so now we need to find out how many of these will fit into here to find out how many minutes it will take. So we have 45 divided by 0.75. Definitely need a calculator for that one. So 45 divided by 0.75. And when we do that, you get 60. Okay? So the answer was 60. Now because this was in minutes, this one here is in minutes. So your answer could be 60 minutes. Or if you wanted to, you could have said 1 hour. Or you could even give your answer in seconds or something. But the point is you must say what your working is. Is it minutes, hours, etc. Well done for getting this far. I hope that was useful and hopefully it goes well. Well done. Bye.